Hello and welcome to this presentation on DirectX11 Picking. It sounds like an odd name, but picking is the process of using a two-dimensional mouse interface to select an object in a three-dimensional scene. This can be somewhat challenging. When you work in 2D, you can fairly easily take a rectangle like a sprite or a button or even a circular area and determine pretty simple if a mouse coordinate falls within that area. In 3 dimensions it's a little more complex. We have two-dimensional integer mouse coordinates when we move the mouse around, but our world is actually a 3-dimensional scene. So how can we select an object from a two-dimensional mouse to a three-dimensional scene? That's what we're going to go over today. There's 2 key parts to this process that we refer to as picking. One is, since we know that we're able to convert 3D position data into 2D screen data, and one of the primary pieces of math involved in that is multiplication by the world view and projection matrices. We know that we can project 3D vertices onto a screen. Shouldn't it be possible to go the other way? Maybe unproject a screen coordinate into some type of world coordinate. When we do this unprojection, instead of getting a 3-dimensional point, what we're actually going to get is a line that goes from the near plane or from the camera through the mouse coordinate on the screen out into the world, and we call this line a ray. Once we have that line or that ray, we need to know if it intersects or hits anything, and if it does, then that might be the object that the user is selecting or picking. The first part is this unproject, and fortunately DirectX has a function called vector3 unproject. And here's an example of it being used. We pass in the mouse x and y put into an xm vector. So we put in the mouse x and y and a small value that would represent maybe the near point, the near plane. Some people put in 0 here, and then the W is not really used, so I don't know that it really matters what you put there. And then we come up, when we do the unprojection, then it projects this into a point in the world, and we pass in this RO on this RO in screen coordinates, this ray origin, this point in screen coordinates, and we pass in the upper left and right coordinates of the viewport. So in our case it's 0, 0, and we pass in the width and height of the viewport. We pass in the minimum and maximum Z value in our depth buffer, and that, if you recall, was set when we create the depth stencil buffer. So when we create this viewport, we have a minimum max depth of 0 and 1, and we use that as the depth values in minimum maximum depth values in the depth buffer. So when we clear the depth buffer, we set it to that maximum value of 1. We also pass in the projection and the view and the world matrices that we've used before. And this gets us a three-dimensional point in what we call local coordinates. So the coordinates of the coordinate system of our objects before they are multiplied by the world transformation. So a lot of times we create a box that goes from 0, 0, 0 to 1, 1, 1, and then we scale it, transform it so that it's much larger. And that scaling and transformation puts it in what we refer to as a world coordinate system. If you want the ray in the world coordinate system, then you would pass in the identity matrix here. But in this particular case, we want it in local coordinate system, so we pass in all three, and it's able to unproject this point into that local coordinate system. We do the same thing for another point we're calling RD screen, and it's the same mouse in X and Y, but instead of starting at a small value, it goes to a larger value like 1, and then we take R0 to be the origin of the ray, or the beginning point of the line, and we modify RD so that it's the point RD minus R0 normalized. So then RD becomes the direction. So a ray has a starting point R0 and a normalized direction vector that goes off to infinity. And using that, then out of the DirectX toolkit there is a ray object, and we can define the ray and initialize it to having a certain ray origin and ray direction. Another interesting thing this brings up is if I can create a ray in local or world coordinates, could I also use it for shooting? And absolutely you can. You can click on something with your mouse and maybe a shot's fired, and you can have an effect. If it hits anything, you can put off some type of effect or have it disappear from the screen or start to make some simple gameplay. The next part is, once we make the line or the ray, how do we know if it hits anything? So in the image here we've got a line that goes through the screen out into the world, and it hits a couple of objects. It turns out that there's an entire topic called ray tracing that attempts to create more realistic graphic images by sending out a ray from the viewer through every pixel on the screen out into the world and see what it hits. And if it does hit something, send out a ray to light sources to see if there's shadows, and do other much more complex lighting effects. We don't use ray tracing in computer games because it's very computationally expensive to compute ray intersections for every ray, for every pixel on the screen, for every frame. That's very computationally expensive. There have been some attempts at creating real-time ray tracing, and you can find some of that online. But the nice thing about this topic of ray tracing is that the intersection of rays and things like spheres and boxes and polygons and triangles are well known and well studied. So the algorithms for computing these ray object intersections are well known and well understood. When we do the ray object intersection, the result we'll get will be a Boolean, whether it hit or not, true or false, and the distance along the ray, so the distance from the ray origin to the intersection point. And then if we want to actually compute that intersection point, we can by taking the origin of the ray plus the ray direction scaled by that distance, and that will give us the intersection point if we need it. In the demo I'm going to show you here, we just want to know if we hit something and then do something about it. So let's take a look at the actual code that does this. The first thing we need to do is detect some mouse interface. So in our event handler, I've added a event handler function or some code for Windows message left button down. And the X and Y position of the mouse are what we call the low word and the high word of the L parameter of the message. So once I have the X and Y position of the mouse, I can call this function called picking test. And it accepts mouse X and Y. And in this case, I'm looking at billboard 2, so I've got 3 billboards in my scene. I've got the sky in the background, and I've got 2 penguin billboards. And I'm looking, billboard 2 is one of those penguin characters on a 3D rectangle. I get its world transformation matrix. I get the view and the projection matrix from the camera. And I set this ray origin and ray direction in screen coordinates using a small value of z and a larger value of z. And then we do the unprojection and compute the ray as we've seen. So now I'm going through each triangle in billboard 2. So each triangle is billboard 2's index list size divided by 3. I get the index in the vertex buffer for the points. I use those indices to look up the position of those 3 vertices and store them in these float 3s. And then I call this nice function ray intersects. And this ray intersects comes from the simple math header of the DirectX toolkit. So I do the intersection and I store the result, the Boolean result, in ray hit. And if the ray is hit, then I set this billboard 2 rotation value to 3 plus 360. So this is actually like a rotational speed, so that it would rotate 360 degrees roughly every second. And in the update, I use this if the billboard rotational speed is greater than something really small, I use it to compute an angle times time. So I take that rotational speed, multiply it by time, add it to the rotation angle, and then set the second transformation. So when I created the billboard, I created it with at least 3, 4 transformations. And the third one here is 0, 1, 2, so the third transformation is the rotation that we're using. And then at the end of each update, I reduce the speed by 90 degrees per second. So if the ray hits billboard 2, it'll start spinning. Let's take a look. So if I click on the sky, nothing happens. If I click on this guy, nothing happens. If I click on this guy, he starts spinning. And if I click on him, he increases the speed and spins. And eventually slow down and stop. And so this is an example of taking a 2-dimensional mouse coordinate and converting it into a 3-dimensional ray using unprojection, and then seeing if that ray hits anything, and then doing something about it. So this concludes this presentation on DirectX Picking.